So hi, I'm Randy Shoup, and I wanted to talk about Pragmatic Microservices. And this talk sort of came out of, I've spent the last couple of years evangelizing microservices. I've worked at Google and eBay, so a bunch of environments where we did microservices a lot. And then it became clear that everybody was talking about how great microservices are, but nobody was talking about how to make the decision to go to microservices and to give people a sort of principled way of deciding whether to go in that direction or stay with what they have. So how many people are already on a microservices architecture in the room? Oh, surprising amount, so maybe a quarter of the people. So this talk is more for the 3/4 than for the 1/4. Cool, so this, like I said, I used to work for Google and for eBay, and a lot of the things that I'm going to talk about here came out of conversations that went something like this. So I live in Silicon Valley and I advise a bunch of startups, and conversations would go, hey Randy, tell us how you did stuff at Google and eBay. And I'd say, sure, I'll be very happy to tell you, but you have to promise me not to do it, at least not yet. So large-scale architectures that are the sort of poster children of microservices evolved. They didn't appear as microservices in the beginning. So to take an example from eBay, depending on how you count, eBay is on about its 5th generation of its architecture. So it famously started as a monolithic Perl application that the founder wrote in a 3-day weekend in 1995. It then moved to a monolithic C++ application that at its worst was 3.4 million lines of code in a single DLL. So please don't do that. It then migrated to a Java-based infrastructure, which was partitioned but not really microservices, a bunch of parallel applications. And finally, I think it's fair to characterize the current eBay as a microservices architecture. So Twitter went through a similar evolution. So depending on how you count, Twitter's on about its 3rd generation of its infrastructure. So it started famously as a monolithic Rails application, which my Twitter friends tell me was nicknamed the monorail, which I thought was quite clever. It then moved to pulling out a bunch of the front end into JavaScript, a bunch of the back end into services, mostly written in Scala, and now Twitter is a polyglot set of microservices. And Amazon has gone through a similar evolution. They're not so clear. There aren't so clear a distinction between the architecture sort of boundaries. But it started out as a monolithic C++ application, a bunch of services written mostly in Java and Scala, and now Amazon can be characterized as, again, a set of polyglot microservices. So there are 2 things to notice here. One is that companies at large scale ultimately end up evolving to microservices. Absolutely true, and it's absolutely the right choice for them at large scale. But none of them started that way. Right? So I think the key thing to take away, and what I want to leave you with, is thinking about the steps along the way in the evolution and making the right choice for where you are now. Or another way to ask the question is, are microservices really the right solution for every problem? And I think the answer is no. So to break it down, I wanted to talk first about some monolithic architectures. Then I wanted to talk about some of the characteristics of microservice architectures. Then I want to talk about the re-architecture decision. How is it and when are we going to make the decision to re-architect potentially? And finally, I want to give you some suggestions from successful re-architectures that I've been involved with about some tactics and strategies you can use to make that re-architecture successful. So first I want to talk about monoliths. So we like to feel sometimes that monoliths are bad and we should feel ashamed of them. But as you heard a moment ago, all those companies that we've heard of and maybe use every day all started as a monolith. And there are actually real advantages to having a monolithic approach, right? It's certainly simple at first. It's a very simple approach at small scale. All the latencies within a monolithic application are in process, so it's quite fast. Typically, it's a single code base and a single deployment unit, so that has some nice operational simplicities. And it's very resource efficient at small scale. There are lots of cons that come along with monoliths too, mostly that occur at larger scale. So the coordination overhead grows substantially as your team size grows. And Rodrigue's excellent presentation about Zalando earlier today gave some really crisp examples of that. There's poor enforcement of modularity, which Adrian pointed out in the keynote this morning. So there's nothing that's going to force you to be properly modular between individual components in a monolith. You also get poor scaling. So typically in a monolithic application, you only get the vertical scaling option. You don't have the option to break it up into smaller horizontal pieces. And finally, the monolith tends to be a single point of failure, both in terms of bugs and in terms of sort of operational availability. But when you have a monolithic architecture, maybe the most sort of monolithic aspect of it tends to be the database. And this is actually something that my current company, Stitch Fix in the US, is wrestling with right now. So the pros of having a monolithic database are, again, that it's very simple. It's simple to have everything all in one place. Join queries, where we want to join multiple entities together and do queries across multiple tables, are very easy in a monolithic database. You get the benefit of transactions. So that actually has some really nice properties. Makes life a lot easier, certainly. And then again, it's very resource efficient at small scale. But the problems that happen with a monolithic database tend to again happen at larger scale. So the database tends to be a coupling point for your team over time. At larger scale, it becomes a performance and a scalability bottleneck. It can be difficult to tune a monolithic database properly, right? If a database is doing lots of different things, as Adrian pointed out in the keynote, if it's really your kitchen sink, then it's hard to tune it for any one particular use case. When you're using it for bulk reads, large-scale queries, fast reads and writes of individual records, all those things are, different tuning would leverage different tuning approaches and are difficult. And if you have one database that's doing it all, it's difficult to tune it in a global way. And then finally, the monolithic database becomes a single point of failure. But if you're in a monolithic situation, you can set yourself up for success even without moving to microservices. So one of the things that I strongly recommend is exploiting the natural partitions in your problem, right? So lots of different problem areas that we face every day in our naturally partition into separate areas. So if you're writing an e-commerce site like eBay, that naturally partitions into the buyer side and the seller side. If you're writing a ride-sharing application like Uber or Lyft, that naturally partitions into the rider side and the driver side. And similarly, search engines naturally partition into the crawler, the indexer, and the query engine. So the next thing that you can do is force yourself and force your team to have the discipline around keeping modular boundaries within components. So, I'm old enough to have no hair anymore, and 25 years ago we didn't have microservices, but we did have modularity, right? So it's definitely possible, even in a system where there's one application or one binary, to have modular divisions between individual components. And that internal componentization gives you a lot of the cognitive benefits of distributing into microservices. And also, as you decide to move to something more like microservices, it makes those individual components easy to modify or replace with a remote service. And then the final thing that is critical, I think, to sort of a healthy monolith is the ability to do continuous delivery. In other words, the ability to do rapid improvements, rapid releases to the code. And that allows you to rapidly evolve the monolith, and it also, as we'll see in a moment, allows you to rapidly evolve from a monolithic approach into microservices if that's the way that you end up wanting to go. Okay. So that was a brief tour of monoliths, and now I want to talk about microservice architectures. So it's a bit funny that we've gone a ways talking about microservices today, but I guess we haven't really defined them. So to me, the important characteristics of a microservice are that it be single purpose, that it have a simple, well-defined interface, and that the individual services in a microservices architecture be modular and independent of each other. And something that we'll talk about a little bit later is, in order to be really successful, by contrast to the monolithic database that's maybe shared with lots of different parts of the system, in order for microservices to really be successful, we need the individual services to own their own isolated persistence. So now you might look at something like this and say, this is a new idea. Well, the word microservices is relatively new. It's only a couple of years old. But the concept of dividing a system into these individual independently cooperating components is quite old. And to my mind, microservices, despite the fanciness of the word, are nothing more than a service-oriented architecture done properly. So I want to talk now a little bit about the sort of pros and cons to microservices. So one of the nice advantages of a microservices approach is that each individual unit is simple. That's the idea of the microservice. It's a very simple individual component. You can now independently scale. You can independently scale them, and they can have independent performance characteristics. You can also, I think this is less well appreciated, because the microservices are small and independent, it's a lot easier to independently test and independently deploy them. I mean, that can be a real advantage in a large-scale system. And then finally, because microservices are single purpose, it allows us to potentially optimally tune the performance of that particular part of the system. So we can introduce caching, for example, behind the service interface, or introduce a more appropriate data structure or data storage mechanism, which allows us to tune the performance of that particular part of the system optimally. Some of the cons of microservices are that, okay, each individual unit is simple, but now you have lots of different cooperating units. And the complexity of the system has changed. So it's now we have individual simple units, but some of the complexity of that system has moved toward the interactions between the units. And if we don't have really good monitoring, as I'll talk about in a moment, that's going to be a place where operationally and sort of development-wise, we're going to be blind to those complexities. So we've also, in microservices, now replaced those in-process latencies now with network latencies. So now we need to be a lot more careful with making calls in parallel, making calls asynchronously, dealing with all the issues of relatively longer latencies for the calls than we might be used to if everything was all in process. We've lost the ability to do transactions. There are lots of things we can talk about separately, if you'd like, about ways we can get some of the nice benefits of transactions back, but you don't get them in a nice, easy, free way. And microservices also are a situation where we require a lot more sophisticated tooling and a lot more dependency management than we're used to with a monolith. So one of the things I want to talk about now are some of the prerequisites for being successful with microservices. And you'll see some major parallels with what Rodrigue talked about earlier this afternoon, because he's actually really lived it. So I first want to talk about process maturity. Then I want to talk about organizational maturity, and finally operational maturity. And I think if you don't have all these pieces in place, that you should work on dealing with these pieces before moving to before moving to microservices. So the first area I wanted to talk about is in process maturity. And here I want to highlight the idea of continuous delivery. So it's a nice to have in the monolithic world. It's an absolute requirement when we're in a microservices world. So what we need to have happen before we can successfully deploy a microservices approach is to have a really repeatable deployment pipeline where we have low-risk push-button deployment. It's really easy, maybe one line in a command line or a button in a UI. That allows us to do a really rapid release cadence, so we're able to release potentially multiple times a day. And also, critically, allow us both to roll back and to recover when those deployments don't work well. The other aspect of continuous delivery that's important here is to have a strong emphasis around automated testing. And all of the places that I know that have really done well with microservices have adopted automated testing straight away. So it's important here that the developers are writing the tests and code at the same time. So as I'm not done with my feature or my change to the system until I've both written the code that implements the feature and also written the code that tests the feature. It's less important to me whether it's test-driven or test-first, but I'm not done with that piece of work until it's both written, works, and is tested. And this gives us the confidence to make risky changes to the software and to release it potentially multiple times a day. And then the last element here of continuous delivery is continuous integration. So by definition, a microservices architecture is a system where there are lots of cooperating components, lots of individual microservices flying around. So it's important that we be able to test the interaction of those system components before we do deployments. So we can understand that those interactions are going to work correctly in a safe way before we deploy it. So after process maturity, I want to talk about organizational maturity. And I want to mention again the same thing that Rodrigue mentioned earlier about Conway's law. So as you heard earlier, Conway said in 1968 that essentially the organization of software, of a software organization, constrains the architecture that we're going to produce. And in particular, the design of the system is going to be a reflection of the communication paths within the organization. So he meant this as a descriptive situation. He was describing the scene that he saw in a bunch of organizations that he'd worked with. But what he noted is that a modular system, a system that has something like microservices, actually requires a modular organization. And so when we have small independent teams that are able to operate autonomously, that ends up leading more directly to more flexible and composable systems. Whereas when we have monolithic teams that are large and interdependent, that ends up leading to more monolithic, more interdependent systems. So there's a direct relationship between the organizational structure or the organizational architecture you have and the software architecture that you're going to be able to produce. And so we can use this not just in a descriptive way, but also in a normative way, meaning we can, in order to get the system that we want, we need to engineer the organization. So one of the things that I strongly recommend is if you're considering moving to microservices, one of the first things you should consider doing is breaking up your organization into smaller pieces that parallel the services that you want to build. So a little more detail on that. I like to talk about this. I like to talk about the microservices organization in the form of service teams. And this is a term that we used at Google. Amazon and Netflix also talk about these things similarly. So individual service teams are aligned with particular domains of the business. So each team has a clear, well-defined set of responsibility, and an individual team is typically responsible for one service or a small set of related services. Those teams tend to be cross-functional. So, what we're trying to get here is that the team is self-sufficient. The team is basically able to get its job done without needing to involve lots of other teams without having to talk with lots of other teams in a very high bandwidth way. Now, obviously, no team is able to do everything on its own. It should rely on other teams to provide, supporting services, supporting libraries, and supporting tools. But that's more of a hands-off relationship. Most of the work that an individual team would need to do is isolated within the boundary of the team. And then the other important discipline here is that teams should have end-to-end ownership of the software that they build, right? So the team owns the service all the way from design through to development, through to deployment, all the way to retirement. So when I started in software, it used to be that our team was done when we threw the code over the wall to the operations team. Now that was a terrible situation for both the development side and the operations side. Now, a team is only done when the service that they're providing is no longer being used by anybody, right? A team is only done when a service is retired. And this very much parallels the DevOps philosophy of you build it, you run it. So the last prerequisite that I want to talk about is an operational maturity around monitoring. So in order to be successful with microservices, we really need to have a strong practice within our organization of highly detailed end-to-end monitoring of production systems. And what we need here is the ability to detect and alert on issues that occur anywhere in the system. And the way to understand whether we've got that or not, the metric that you can use, is we need to be able to have sufficient monitoring in order to be able to remotely diagnose issues that occur in production without having to log into the individual machine. So the thing that I like to say here is, if you ever have to SSH into a machine to debug a problem, it's because your monitoring has failed you. So that's a bit about the microservice architecture and some of the ways that we can be successful with microservices. Now I want to talk about the decision process that we would go through to move potentially from a monolithic system into microservices. So I want to ask the question, why are we going to re-architect? And there typically tend to be one or several of three answers. So the first reason that we re-architect tends to be around velocity, or in Rodrigue's example from Zalando, he talked about this in terms of innovation. So here, the reason why we would change is because our time to market is being constrained by the lack of isolation or the coupling that we find from in the monolith. Also, another example is that teams could be stepping on each other's toes while trying to get their work done, right? So teams are no longer really able to develop independently because the interactions within the monolith are too difficult to deal with. And then also the other metric is how long does it take for new engineers joining your team to be productive? Or more precisely, how long does it take new engineers to be able to feel safe that they can check something in without breaking something, right? In addition to velocity, oftentimes other organizations will think about it from a scaling perspective, right? So there may come a time when vertical scaling of the monolith no longer works. So it's no longer enough to scale to the load that we're experiencing. And that parts of the system might need to scale at different rates from others. This was certainly something that we experienced at eBay, where lots of different pieces of the system would scale at wildly different rates than other parts. And so when it was in a monolithic situation, we were kind of constrained, and when we had an architecture where things were more divided, it was a lot easier to be able to scale those different parts of the system independently. And then the last reason to think about re-architecting is deployment. So parts of the system might need to be deployed independently of others because maybe they're on a different life cycle. So some parts of the system tend to evolve really quickly. Other parts of the system are more stable and evolve more slowly. And it may be that the monolithic release cadence is too slow, or it's too complicated, or it's too risky. So that can be other sort of decision criteria that you would use to think about whether to move from a more monolithic approach into microservices. So as an engineer, I look at this and I go, well, if I'm already going to end up in microservices, why don't I just start there, right? And isn't the fact that I have to re-architect along the way, doesn't that mean that I didn't do my job? I actually like to think of it a different way, where I like to think of getting to re-architect a system is more a sign of success than it is a sign of failure. And why do I say that? There are lots of startups in the world, 90% of them fail. There are lots of systems in the world, 90% of them aren't appropriate for microservices because they're too small or they're too simple. When we get to the point that we want to re-architect a system, or that we feel the need to re-architect a system from an older architecture into a newer architecture, often that's a sign that the business model that we're pursuing is really successful, right? It means that we're doing something that people actually care about, and typically we have the resources in order to apply to doing the re-architecture. So this, I can't say often enough to the startups that I advise. This point of re-architecture is really a sign of a successful trajectory more than a problem. And if you don't believe me, again, we can think about the examples that I showed earlier: the eBays, the Amazons, the Twitters of the world. Every single one of those, well-known applications that we use all the time, has gone through one of these architectural evolutions. And no system that I can think of any company I've ever heard of, has the same architecture today as they did when they started. So the other way I like to think about this is, if you don't end up regretting your early technology decisions, you probably over-engineered. And there may well have been another Twitter competitor that, rather than doing something really simple with Rails, started out building a great distributed system that was going to scale them for the next 5 or 10 years. There's a reason why we've never heard of that, heard of that company. There's a reason why we've never heard of the eBay competitor or Amazon competitor that started out building a distributed system rather than a monolith. It's because the companies that were successful focused on meeting the needs of their customers, finding a business model, making sure they had product market fit, and moving forward in a sort of evolutionary way rather than over-engineering from the beginning. So the last section that I want to talk about here is, okay, Randy, I do feel like I'm in the situation where I want to re-architect a microservices. So now I want to offer you some suggestions that, of tactics and strategies that have worked reasonably well in the past. So the one thing I would absolutely recommend to start with is, do not do it as a big bang. And Martin Fowler has a wonderful quote here, which I love, which is, the only thing a big bang migration guarantees is a big bang. So would much more strongly recommend thinking about a re-architecture as an incremental step. So how can we keep the current system running and at the same time move incrementally over from an old architecture to a new architecture? And the analogy to distributed systems is a re-architecture is more a rolling update than it is a blue-green deployment. Does that make sense what I'm saying? Okay. Great. So how would we approach incremental migration? So the step 0 that I often recommend to people that I work with is do a pilot implementation first to convince yourself that the new architecture, whether it's microservices or whatever, is going to work for your problem domain and within your organization. And what I recommend is that you choose an initial end-to-end vertical experience and migrate that thing, rather than taking an individual piece to start with. The reason that we want to do this sort of pilot is we want to take the opportunity to learn and to adjust as we are doing this new architecture. We also want to demonstrate the feasibility and within our organization and gain the confidence that we can have this work with our technology team, with our technology stack, and with our business problem. We also, at the same time, we want to bound our investment and our risk. So we don't want to do a big bang re-architecture straight away. And at the same time, if we choose a real customer problem, we're actually providing real customer value while we're doing this re-architecture. So that's the step 0. And actually, this initial step tends to often be the hardest because this is the time when we're actually learning how to do the things in a new way, and we're actually building out the basic sort of building blocks, the basic capabilities in order to move to microservices. So once we've done that, now we should take an incremental approach to migrating the rest of the system. And my strong suggestion is that we actually think about it from what's the most important business value and sort of what's the most important part of the system, and try to do that first. And that seems counterintuitive. It seems like maybe that's a risky approach. But this is exactly what we did at eBay, where we sort of looked at all the pages on the site and reverse sorted them by contribution to revenue, and we re-architected the highest revenue generating pages first, and then went down from there. And the reason to do this, despite being counterintuitive, is that this allows us to focus on the areas that typically have the greatest change. So it's the stuff that we're actually working on, we'd be working on anyway. It also maximizes the near-term benefit and then sort of the near-term payoff that we get from the investment in the re-architecture. And it also forces us to confront and solve a bunch of the hard problems that we would face earlier on in the cycle, rather than waiting till the end to face the real difficult challenges. The other interesting thing, which also came out of the eBay experience, is that it may be that as you keep going down from sort of highest business value to lowest business value, you may end up having a monolith that stays around forever. So when I left eBay, eBay had been doing its re-architecture for 6 or 7 years when I left in 2011. At that time, there were still pages that were on that previous version 2 of the architecture. But those pages were the pages that really nobody cared about. They never changed. They weren't getting much traffic. And so we had, by doing the sort of solve the biggest problem first and then leave the rest to later, it allowed us to kind of migrate those other pages or those other pieces of the site very opportunistically, and forced us to think carefully about where was the most business value we could get from this re-architecture investment, rather than doing the easy stuff first. So now a bit of tactics about carving up the monolith itself. So the first thing I would like to suggest is that we look for or potentially refactor in order to create a seam within the monolith. So we found this area that can be sort of separated from the rest of the monolith. And again, often there's a lot of work associated with refactoring to make this be the case. So then the next thing we want to do is wall that off behind an interface, and all the interactions to that component are going through that interface, but it's still in process with the monolith. So the next thing we want to do, if we don't already have strong automated tests around this area, we want to write a bunch of automated tests around that particular component. And only after that do we want to move the implementation of that component out into its own remote service and replace it with a sort of microservice. and then we want to rinse and repeat. Every time I give this talk, I have the feeling that this seems too overly simplistic, but every other re-architecture approach that's sort of more complicated or has more steps than this, I've found not to work as well as this approach. It's very simple, but it's very step by step, and it's very sort of procedural, and allows us to make lots of forward progress. So the final thing that I want to mention here are some anti-patterns that, as we're moving to services, that we might run into. And so the first one I want to talk about is, by contrast to the microservice, the anti-pattern here is I like to call the megaservice. And this is a service where it has a really overbroad area of responsibility. So it's not single purpose. It's not a well-defined small interface with a small surface area. And those types of megaservices tend to be really difficult to change, really difficult to evolve, and it also it leads to very unsustainable amounts of dependencies. So, that service that does quite a lot has lots of upstream dependencies on other services or applications, and lots of downstream dependencies as well. So don't do that. And by the way, as a side note, I think lots of the failures that our industry had in first trying to move to service-oriented architectures came because we built services that were too overbroad. Right? That certainly was my experience. And so one of the reasons why I think the industry has correctly shifted toward thinking about services as microservices is trying to avoid that problem, trying not to build services that have overbroad areas of responsibility that are essentially other little mini monoliths in our system. So the next anti-pattern that I want to talk about is something that I call the leaky abstraction service. So the idea here is that when producing the interface, the service provider didn't think about it from the perspective of the customer, but only thought about it from the perspective of what was it going to take the provider to produce, like essentially leaking implementation details of the service into the interface. And there are lots of reasons not to do this. Most powerfully, it's because this consumer's model of the service often tends to be a lot simpler. So the consumer's approach tends to be more abstract and tends to be a lot simpler than the implementation. And also, as a service provider, if we leak our implementation model into the interface, that makes it really difficult for us to change it, which constrains our ability to evolve that service over time. So the last thing I want to talk about, the last anti-pattern that I want to talk about here is shared persistence. So when we have a situation where we have a nice interface at the microservice level, but we share a database or some other persistence mechanism with other services or other applications, that actually completely breaks the encapsulation of the interface that we expose to our clients. And it actually encourages, or at least allows, other parts of the system to kind of make backdoor violations of the interface behind our back, sort of directly in the database or directly in the persistent store. And what that ends up leading to is a very unhealthy coupling, but that's near invisible, very unhealthy coupling between those two services that are kind of also sharing that same back end. And this was one of the main reasons why eBay's first foray into service-oriented architecture around 2008 was a big failure. In the end, it has worked out fine because they've approached it in a different way. But in 2008, the approach at eBay was to partition the application tier. So there were lots of applications that were, here's selling, and here's buying, and here's search, and nice partitioning of the application tier. And they did a decent job also of partitioning the service tier. So here were services around authentication, here were services around checkout or billing, but the underlying databases underneath those services were still shared. So what happened was, in practice, nobody used the services or the service interfaces. They just continued to go directly to the databases where they always had been. And the services, all the effort that we put into building really nice, clean services ended up being wasted effort. Okay. So in conclusion, I think it's fair to say, as wonderful as microservices are, particularly at large scale, I want to leave you with the idea that microservices may not be for you if you have a simple system, right? If you have a small team of developers, If you're not able to invest in a bunch of those prerequisites that I mentioned before, can't invest in continuous delivery, can't invest in monitoring, are unable to change their organization around small service teams, and most importantly, microservices aren't for you if they don't solve the problems that you actually have. So thank you very much. So I think we have a few moments.
Yeah,
for
we
questions.
actually had a lot of questions.
Great. All right, fire away. And I'll be here the rest of the conference too, so we can.
Yeah.
Do that.
So
yeah.
Go up and talk to him afterwards if you don't get your question in here. So there seems to be some confusion about why you would say don't do microservices from the get-go. Because why would you suggest that you should make a monolith from the start? And let me just interpret some of that, because I think the word is actually, or the problem is the word monolith here, because that indicates something large. And usually applications are not from the start, right?
Yeah, right. No, that's an excellent point. Yeah, why would I not just move to microservices? Because when you have 10 users or 100 users or 1,000 users, you shouldn't be spending your time building a distributed system. You should be spending time building the application that your users actually need to use. So it's a matter of opportunity cost. It's a matter of what's the most important thing I can spend my development resources and my machine resources on right now. And in the early stages of a company or an application, it's completely wrong to think about building something that's going to be 5 years down the road or 10 years down the road. Startups that work that way don't tend to work out.
Another question is, so you just mentioned that you shouldn't do integration through the database, right? But in the beginning of your talk, you said that you guys had that problem right now.
Oh yeah. So once you're in that, so one of the challenges of moving from the monolithic approach into microservices is that you have to start to sever those integration points within the database. Again, the idea in the early, when you think about it as different life cycles of a person or different life cycles of a company. In the early stages, you shouldn't try to solve the problems that are only going to come later on. So in the early stage, when again you're trying to figure out whether you have a business model, whether you have product market fit, or whether your application is actually going to be used by your users, you should make it as easy as possible to move forward. And often at small scale, that's a monolithic application with monolithic databases. And then if you should be so lucky as to have to end up having a much larger scale situation, that's the appropriate time to invest in that longer term approach. And the investment that you would make earlier on, in my personal opinion, is not the best use of your time and resources.
Okay. We also had quite a lot of questions about testing and how to actually do it in practice. Because you mentioned that you should build a test harness around a component in your application that you would rip out and make into a microservice. But at that point, the tests that you do could be unit tests. And all of a sudden, they might be interface tests instead, right?
I think I see what you're asking. So, I mean, you're asking generally about testing, so as we introduce that interface around the component that we're about to pull out, what we're trying to achieve with testing here is to make sure that in pulling it out we haven't broken anything, right? And the best way to do that, honestly, the only way to do that is to write tests that exercise that component up front ahead of time before moving it. If we wait to write tests after we've already sort of extracted it, that's too late because we don't know, we can't know whether we've changed behavior or not. So you have to do that earlier on.
So while we're on the topic of changing behavior, so say that you have a couple of microservices. How do you test that if you change one of them, that they are still compatible? How do you test several microservices at the time? Yeah, right. It's like Adrian was saying a moment ago. It's sort of defense in depth, but testing in depth. So the first thing that we can do to test a microservice is to test that component in isolation, right? So to write tests against the interface directly, and to the extent that we have other services that microservice interacts with, we should mock them out. And this is something that we did
super heavily at Google, where every time we would build a service, we would spend most of our effort, our testing effort, around testing that service in isolation and then mocking out the interactions that system had with that service had with other parts of the system. And that is easy because you're doing it in isolation, but it also allows you to simulate lots of failure modes that would never occur or would only rarely occur in real life, right? Something that happens, 1 in a million or 1 in a billion times in production, that's really hard to simulate by running it a billion times, but it's super easy to simulate it by mocking out that interacting service there. So then that's at the service level. Then the next level up is sort of an integration test where we could test the system, test a running system altogether, and that allows you to do more end-to-end related stuff. One more thing I'll say about here: it's not really about testing, but the critical discipline that you need to have in terms of making sure service interactions continue to work is backward compatibility and forward compatibility of the interfaces, right? So the critical discipline is that if my service A is talking to service B should be able to modify itself and deploy independently, but that only works if the deployments that service B does don't break the interface that I'm expecting. So that's almost, that's almost the step 0 that's before testing. Does it make sense what I'm talking about? Okay.
There's been a lot of talk about domain-driven design in relation with microservices. Mm-hmm. Is that something you've used yourself, or is that something you consider when you design microservices?
Yeah, I think domain-driven design is super powerful in microservices. I don't think it's a requirement, but Eric Evans' approach, particularly to bounded context, is a really wonderful way of thinking about. It's a wonderful kind of architectural discipline and architectural philosophy to apply to services. So I think domain-driven design works very well with microservices. Is it a requirement? I don't think so, but it's super powerful, and if you're already a fan of it, microservices will be a lot easier for it.
So final question, it's in relation to distributed transactions. Mm-hmm. So you rip out a couple of components from your application, and then you realize, oh, we actually need a transaction across this. Is that already too late, or can you use something like distributed transactions, and are there any good tools for that? Yeah, sure. This is a talk in itself. Well, obviously, if you've ripped something out and then decide you need a transaction, well, that is too late. But you're thinking about it. Whoever is the questioner, you're thinking about it ahead of time. So I'm sure you won't wait till that time to figure it out. Yeah, that's a challenge, because as soon as you have split the persistence of a thing between two databases, for example, the transactions become a challenge. Distributed transactions, I really don't like. For reasons I'm happy to talk about offline. There are a serious availability and scalability bottleneck, but you can do techniques around reconciliation of changes that have you basically have to asynchronously introduce the consistency sort of after the fact. And I'm happy to talk with people afterward, because there's sort of a lot more complexity than I'm able to do in one sentence. But I'll give the quick example of when banks are doing transactions between banks. They don't do distributed transactions, right? When Deutsche Bank and Bank of America are doing a currency trade, that's not a distributed transaction. That's something where they do the transactions during the trading day, and then they reconcile at night. Does it make sense? They send each other files. I saw these 999,999 transactions. Oh, I saw these 1 million transactions, and they reconcile. So that's one of many approaches that one can take to getting the same consistency effects of transactions, while at the same time having two independent components that aren't transactionally bounded. I hope that was helpful. Thank you, Randy.
Great. Thanks.